In this series, we are going to be covering databases that every developer should try out and test run and have a little bit of experience with. Most developers these days have experience with MySQL, Postgres, perhaps MongoDB and Redis, but there are some other ones that are really great that are out there. And in this video, we are going to cover ArangoDB, also called ArangoDB, depending on who you talk to. For the rest of this video, I'll probably call it ArangoDB, but from the best I can tell, there is no right or wrong. So ArangoDB is a really cool, really unique database. It's a multi-model database, which means you can use it as a graph database, which we'll cover a little bit more later about what graph databases mean, for those of you guys who haven't used graph databases before. It can also be a document database, like replacing a MongoDB type of database. And it can also be a key value store database, replacing something like Redis. All with one query language, you can use any or all features at any point in time. Speaking of the query language for ArangoDB is really nice. Usually when I hear of some new database with a new query language, I have this knee-jerk reaction that I don't want to use it or learn it. Who needs to learn another query language? But ArangoDB, their query language is really easy to pick up, very enjoyable to use, and it's based on coding. It's based on how it feels when you're coding. You take an array, you filter, you map, you sort, and that's kind of how it is. We'll dive more into that later on. You also get everything you expect out of ArangoDB or ArangoDB that you'd expect out of a modern database. It scales easily, it clusters easily, it runs seamlessly in Docker, and also has a really great UI right out of the box, so you can start using it within seconds. It also has some really cool features you might not expect to see. It can be used for search in a really powerful way, allowing it to operate kind of like as an Elasticsearch replacement. And it also has this built-in Fox JavaScript framework, so you can build Nodejs microservices straight onto the database layer itself, which means you can get some really cool performance benefits. It can allow you to do things like make a REST API that the database layer serves, so you don't even need a backend for small apps. So that feature alone is really, really interesting and really cool, and it can fulfill a lot of small-scale use cases and some large-scale niche use cases that large companies may actually have. It can also do geospatial searches. So if you want to search for any items within a polygon shape, it can natively do some searches like that, which is really cool. So enough talk, let's get into this and actually have some fun with ArangoDB. We're going to start by spinning up an instance in Docker. So as long as Docker is installed on your machine, this will work really easy. You just do docker run, and then we're going to add a few arguments here. Arango no auth. This means we're going to disable authentication, no usernames or password. This is just local playing around. We're going to expose port 8529, which is that port, and we're going to call it test ArangoDB. Let's go ahead and run this guy, and ta-da, we are running. So now I can actually go localhost port 8529. And there we go. We are instantly into their UI. It's really nice. We can see our collections, views, which are our kind of Elasticsearch search type of things, graphs, which are how we want to build any graphs. We can natively build graphs on top of our data. So let's go ahead now and add our first collection, add some data in there, and show you how the query language works. Let's create a collection called Friends. And you can see that we have two options for types, document or edge. We'll get into edge a little bit later because that's a graph database feature. And there we go, we have a friends collection. Now I can go over here to queries. We can actually insert some records. It's pretty simple. Just say insert, add any JSON you want, and then you can pick into which collection. So I'm going to do name. You notice I don't actually have to make it official JSON and wrap everything in quotes. That's really nice because it's a lot more annoying to have to wrap every single key in quotes. So I'm going to insert Will into friends. Hit command and enter, and I've run my query. I can come back over here and I have my first friend named Will, which is me. So let's insert some new people here. Bobby. Let's create John. Apparently all my friends are dudes. That's fine. Jake. So we just inserted a bunch of people. We can go back to this collection and there we go. We've got a bunch of people created already. So now how do we actually return some of these documents? Let me look at some of these IDs here. If I go here, I can see that their key, each person got a unique key. I did not specify a key, so each person got a key. Key is basically like ID would be in a relational database. You can specify a key, which gives you basically the ability for key value storage, but when you do not specify a key, one is randomly generated for you. So we've got 501, we've got 514, so I can actually now return just a document. 501. And you can see it pulled back document 501. I can view it in JSON there. There is 501. I can also say, what was it, 514? Is that correct? Yeah, 514. I can also get 514. I can also do an array and get several. I can return 2 documents. Super simple. I can also iterate through if I want to actually do, say, like a where query. Friends, where name is Will, then I can go for friend in friends. And this is where it really starts feeling like code. I can return friend, which is going to give me basically every friend because I didn't really do anything. I didn't do any filtering or anything like that. But I can easily do some filtering. Where friend name is Will. And so now I'm just going to find Will. So that you can see where I could do where friend age is greater than 15, which I haven't put the age in there, but you can easily do all the stuff you do and it just feels like code, which is really, really nice. Let's say we have a collection called states that has all the states in the country, and I wanted to also join that. I could go for state in states. And then I could do filter where friend.states. This would be assuming that I actually set a state, the state that the friend lived in, equals state.key. And then there you go. I can automatically, well, that would be underscore key, wouldn't it? Then I can filter wherever the state is. And then I can also return anything I want. I can return a JavaScript object of friend.name. I can just return a few values that I want, or I can return, say, maybe the whole friend. And also something else. You can basically do it if you can think it in code, you can take care of it here. So let me actually do a little example of how that return object works. If I just return friend, then I'm going to see the entire JSON object of each person. Now, if I actually create an object and add friend in there, then it's going to treat it as if you were doing ES6, and then friend equals the entire friend object. So there's a little bit more nesting going on, and I can add some, actually just add my own pretend value if I want. Now each person gets both a friend and a foobar value. So you can really customize how that output works without having to mess with the application layer, which is really, really nice because lots of times this kind of decorating and laying out the data would happen at the application layer. Okay, let's use this as a key value store now. Let's create a collection. We'll call it sessions. It's document as well. Let's say that we're collecting user sessions and we want to take care of that. So I'm going to insert, I don't know, IP address or logins. I don't really know what we'd want to do for sessions. Let's say logins1 into sessions. But we actually are tracking this with a session key so we can specify that key. We'll just call it ABCDE. Let's pretend that's some big old long hash. And there we go. We've actually inserted ABCDE. So now we can go fetch it whenever we want. I can go get ABCDE whenever I want to. And you can see that it has logins equals 1. So now I'm essentially using it like Redis. I'm setting keys explicitly, and then I can fetch them knowing that they exist. So this is how you would use it for a key value store, simply just by specifying key. That's all you have to do. Super nice. Let's look into the graph database features, and I'll also cover just a little hint of how graph databases work and some of the cool things that you can do with graph databases that you just simply cannot do with relational databases. Okay, so in a graph database, you really have two types of data. You have collections, which are documents, which we've been creating. And then you have lines between those. So picture them circles and lines all laid out in this huge graph. Each document is a circle, and each line is like an event that connects one thing to another. You could think of it in plane flights, where flights connect one airport to another. Or you could think of it as Bitcoin, where there's transactions that happen between one account and another account. So those lines are called edges. So let's go ahead and create an edge collection here, and we'll call it, I don't know, high fives. High-fives. So friends can now high-five each other. If we were to actually create something, there's really two things that matter most if you're going to create a document. I'm going to go ahead and manually create a document here. You see we have this from and this to then optionally a key, and then you can add any additional values that you want. So the things that are hard required is it has to come from a document and go to another document. I have to high five somebody. I can't just high five nobody. So as long as you specify that from and that to, and then you can add anything else you want, you're creating an edge. So I'm going to go into queries right now. Let's go insert from, although I don't know anybody's IDs. Let me go back here and look up some IDs again. 501, 514. I should have remembered that by now. Let's have Will high five Bobby here. So there we go. Will is now high-fiving Bobby, but we can also add any other values we want. So we can say maybe hand coverage, right? How good of a high five was this? Was this one of those awkward ones where we're not sure if we should high five again or not? Yep, it was 0.3. So there we go. We have now inserted a high five into the high fives collection. Let's go check it out. There it is. Da, 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 da. You can see that I've high fived from here to here, and we have some really awkward level of hand coverage. Let's go insert some more high fives. Who else do we got here? We've got 514 and 517. Let's go ahead and create that one. Let's have 514. High five 517. Let's say this was a much better, one of those less awkward ones. Ta-da! And now we've actually created some things. So you can actually go into this graphs view, which is super useful. You can actually visualize the data that's in your database. We're going to look at all the high fives from friends to friends. And then edge definitions are going to be the high fives. So we're going to look up any high fives from friends to friends. Now this could be any product sales from a person to a certain product, or from a person to a certain vendor or a store. If you think about it, there's a lot of ways we might want to visualize data. But in this case, we only have high fives and friends. So this will take just a second. And there we go. You can see that 501 high-fived 514, and 514 also high-fived 517. So at this point, we can actually start doing some pretty interesting searches. I can say, hey, tell me anyone that 514 has high-fived today. Or I could also say, hey, tell me anyone that has high-fived 514 today. Or I could also say, hey, tell me anyone that I've high-fived that has also high-fived someone else, or is also high-fived 517. You can go all the way down the train of things, or you could say, hey, tell me anyone that has eventually high-fived 517 in that chain. Let's go maybe maximum of 5 points of connection between me and that other person. Or if you have a whole lot of data sets, you could query really easily. Tell me anybody that have high-fived today that has purchased a product on Amazon.com and that product has gotten a rating of at least 4 stars, and someone who rated it has also high-fived the president of Ukraine. And you can do queries like that, and it's native in Graph. We'll show you just how easy stuff like that is. So now let's actually do a query. It's going to be really similar to what we've been doing. We're going to go for friend in, and then we're going to do this tricky thing, 1.1. So only 1 degree of separation, right? Somebody I have personally high-fived in outbound. So this means a high five that I have sent off, right? It comes from me to someone else. That's gonna, who do I actually want to see if we're actually looking outbound from me. So let's find Will here, 501. Should have memorized that by now. And then high fives, and we'll return friend. Oh, and I made a mistake. I forgot that I shouldn't have named this high dash fives. That's a big problem because it's going to look at it like it's subtraction going on. So let's just change this to high fives. I'm going to rename my collection. High fives, no dash at all. Now I can come over here, high fives, return friend, and ta-da, we can see that I have high-fived Bobby. So I have this one outbound high five to Bobby. Now, if I change this from 1 to 2, you'll see I actually have 2 results. I high-fived Bobby, but Bobby high-fived John. So with a chain of events that's 2 away, I've essentially chain high-fived 2 people now. Bobby and John. I've kind of got 2 degrees of separation from John, 1 degree of separation from Bobby. I can also change this from 2 to 2. So anybody they've only chained high-fived. Man, this is so hard to say. Anybody that I've only chain high-fived with 2 degrees of separation, you can see only John. I high-fived Bobby. Bobby high-fived John. So Bobby's not in this list because I'm only looking at 2 degrees of separation away, not 1 to 2 degrees of separation. So you can easily do some really interesting queries on the data. I can also do inbound here. And let's see who 517 has gotten any inbound high fives from. He's gotten one inbound from Bobby, and he's 2 degrees of separation away, gotten one inbound from Will. So you can also see if I change this from 1 to 1, then he's only going to get a high five from Bobby. It's native in graph databases to search on degrees of separation and things that would be really, really complex with lots and lots and lots of joins. Take that example I said before. Anyone that I've high-fived that has bought an Amazon product, that has gotten 5 ratings, that has a reviewer, that is also whatever. That's pretty complicated to do in a relational database, but it's extremely native to do in a graph database. You just set up your objects, which would be products and would be people. And then you have some actions between them. You have purchases, you have reviews, you have high fives, and it's pretty simple to traverse all those actions and connect them to all those different objects. Graph databases are extremely cool for solving a lot of very tricky data set problems. So that is your high level of how you use ArangoDB as a multi-model database, working with documents, working with key value stores, and working with graphs. So now let's look into some of its other awesome features. Let's go on to search. I've gone ahead and I have added a movies collection, and I have uploaded a JSON file of the movie lens database. It's movie LENS if you want to Google for this data set. So I have the whole movie lens data set here, which is many, many movies. And I want to actually search them. I want to search their titles, and I want to do it in a quick Elasticsearch kind of way. So the way that I can do this is I can actually create a view. Let's go ahead and create a new view. Let's call it movies view. And you can see that it's automatically created a few defaults for me. It's stuff that I shouldn't have to mess with, at least not right away out of the box. About the only thing we have to do is we have to add some data to the links. The links are the collections that we want to be able to search on. You can actually have this one search view search multiple collections or just one collection. The multiple collections is obviously very, very helpful, as lots of times when people are searching, they'd be searching movies or actors or genres or any of that stuff, and they want to do it all with one search. So we're going to add multiple links, we're going to add movies, and we're going to add friends. There we go. We've added the friends collection. You can see for an analyzer, we picked text English. We've included all fields. And then movies as well, analyzer text English, and included all fields. So now we can go ahead and hit save. And it is going to then parse through our collections, make sure that that is all ready to go. Ta-da! And we are good to go. Now we can run queries against our view itself and search friends and movies at the same time. We can simply go for results. Of course, you can call result whatever you want in movies view. Let's go ahead and do a search. So there we go. We are searching, doc.name. So anything where the name contains this or any of these values, let's return the results. Whoops, not doc. Let's call it result. And ta-da, you can see that it returned a friend. So if I change this to title, title includes Will, then I'm going to see all the movie titles that have the word Will in them. I can also do... I can also copy and paste this search phrase and do an or, so I can search where titles contain Will or where names contain Will. And now you can see I'm going to get a friend, and I'm going to get a whole bunch of movies in my result set. So I can search either or, and instantly with simple little queries could search dozens of results set. So you can see with just a few little moments of setup, I can have a lot of what you get out of Elasticsearch right out of the box. You can get a whole lot more complicated than this. But this is a nice overview of what you can do with search features. Okay, one more feature I want to cover on this high-level overview is the ability to add Node.js microservices straight onto the database layer. I think it's a really cool feature. Let's go to services, and let's go ahead and click upload. But we don't have anything to upload. We need to go ahead and make our service and then zip it up and upload it. So I'm going to go to my code editor, and I'm going to create 2 files. I'm going to make manifest.json, and I'm also going to create index.js. You can call it whatever you want. And then in manifest.json, let's just go ahead and add a couple things. So that is all I need to add in the manifest.json, which engines it should run on, and what our main entry point is, which is index.js. The rest of it from here is doing some Node.js. So I'm going to create really quickly a basic router for you, and then we'll show you how that works. Okay, here is a basic router for the Fox framework. And as you can see, it looks a lot like express.js. I've done a few imports here. Let's grab the database. Let's grab the friends collection. And let's create our router, and then I can just do this, which is a lot like Express. Really, the biggest gotcha is you have to do synchronous operations. You cannot do async operations. There's good reasons why it's in the documentation, but if I just do get friends, you can see that I'm going to send all the friends back. So now all I have to do is zip this up. Let's go ahead and select these two files, compress these two items, and now I can actually drag it and upload it and have my first service going. My mount point will be friends. We're good to go. And now I can go to this URL here. I'm just going to copy DB system up to DB system, and I can go friends. And now I actually have an HTTP endpoint that is going to access my microservice. I can get friends, I can post friends, I can do about whatever I want in this microservice. I can make it to where when you send me a document, I can parse it and normalize it and do a whole bunch of stuff and then save it across 5 different collections. The sky's really the limit. It's a true Node.js microservice that you can do just about whatever you want in here. And off the top of my head, the two best use cases for these Fox microservices would be small projects where you don't want to have to build out a server backend. You want the database authentication to be able to work across your API authentication. You just have a small thing. You need a few REST endpoints. You can add them straight on top of the database layer and call it a day. Also, on these larger use cases, GraphQL can actually be pretty networking expensive sometimes. And so if you add the GraphQL layer to the database layer, it can save a lot of networking with the joining and the normalizing of data. So those are two use cases that pop onto my head right away for what you could use this Fox microservices feature for, but there's a whole lot of things I'm sure you could do with these microservices in ArangoDB. So that pretty much covers it. We've got this multi-model DB that can handle documents, it can handle key value store, it can handle graph, it can handle search, it can handle custom services. You even have some data visualization tools built in the form of graphs. It's almost like a Swiss Army knife database. I mean, you install this, you can get a lot without installing any other databases. It's pretty cool. I really enjoyed it. I think you guys should mess with it, at least know the basics of it, know how to use it so you know that it's a tool in your tool belt that you can go for. Hope you enjoyed this tutorial and have a phenomenal day.